Let's have a quick recap of what do we have here. We actually built a big data model, which is based on union on several types of events. And actually all this is very big. Like we have billions of impressions per day, and we have billions of other events as well. So we kind of need to write them again in Kafka, and we need to add them to Druid. So our clusters should be huge, like Kafka clusters, we should increase it, and we should increase Druid. And also we need to understand the requirements of this system. As I mentioned, we have a lot of other systems in Druid, in Outbrain. So we use Druid mostly for troubleshooting, for analytics, for visual analytics, and also for detecting trends. So we can kind of lose some precision in this system. So when we address the scale, we need to think how to solve this problem with the scale. There are two ways to deal with the scale using Druid. First way is to use rollup. Rollup is a built-in feature in Druid. You define the rollup fields, and the Druid pre-aggregates the data in the ingest time. And actually, you doesn't lose any precision in this case. But for our case, for real-time event, rollup is not good because we have big number of fields, big number of dimensions, more than 100 different columns. So rollup will not help us in this use case. Okay, rollup, you need to be very specific when you use rollup. We use rollup in other use case in Druid. It works great, but for real-time event, we need some other solution. So we decided to sample our data for handle the scale. We bring the portion of the data to Druid. Actually, we sample our data in Spark. It's very easy. Spark has this out-of-the-box built-in function rdd.sample. Okay, you just send the sample rate. All our Spark streaming jobs get sample rate as a parameter. So, for example, we can sample just 1% of the traffic, and that's all. rdd.sample does the job fine. But what happens now? We have portion of the traffic that sample data in Druid, right? How can we work with numbers that we have in Druid? We need to know how many clicks do we have, how many impressions, how many other events do we have, and now should we multiply these numbers? How can we treat these numbers, and how can we uh, let other teams to use Druid? They are not aware of our sampling. So how all this should work? In addition, we sample different streams with different sample rates. For example, impressions is a huge stream. We bring only 1% of them to Druid. But our billing events, like clicks, we don't sample them. We bring all of them to Druid. So we have sample data in one place and with different sample rate. It could be kind of mess, right? So we use some nice trick during the sampling. We calculate sample factor, which is 1 divided by sample rate. You can see it here in this line. Sample factor equals 1 divided sample rate. So if sample rate is 1%, the sample factor is going to be 100. And we actually put this dimension, this sample factor to each event. So we will have this sample factor in Druid, okay? So when we have this sample factor, we actually calculate all normalized metrics for all important data that we need using transformation spec, and we use sample factor in all our expression in all our formulas. You can see that we calculate number of expression, normalize. This is our we sign our matrix with underscore n, so we know that this matrix is normalized by sample factor. So we just take this flag like impression. This is the Boolean flag from the Spark streaming, multiplied by sample factor. So now every event is multiplied. If we sample 1%, it's going to be multiplied by 100 because every single impression now contributes like 100 of impressions. And the same regarding the click, number of clicks, we also multiply it by its sample factor. So we add, actually we calculate normalized dimensions for all important metrics. So our data analysts, they know that they can use it as they don't need to care about the sampling. So this is the fixed formula for gross revenue. As you can see, we added sample factor to each part of the expression, like click, multiple cost per click, multiple sample factor, and the same regarding impression and video event. So when we started sampling, we kind of fixed our Kafka ingestion spec, and we added sample factor to all our formulas. And now it works great. We can trust our numbers in Druid. Sampling helped us a lot to handle the scale. But when our teams started using the system, this data model, we faced the problem that sometimes they need to get some portion of the traffic to be not sampled, to be like 100% of some specific events. So we solved it. We developed internal tool, internal service that enables other teams to define a sample policy. They add this time of event like clicks or impressions. They need to be sampled with this attribute need to be sampled, like clicks for some publisher or impressions for some location or stuff like this. They add event type and which attribute gonna be sampled, gonna be not sampled, like 100% of sampling for some period of time. Let's see an example. So we want to define that we need all impressions for publisher pub 1000. So in Druid, all other publishers are sampled. Okay, like the sample factor is 100. And this specific publisher, pub 100, is not sampled. Like when Spark streaming jobs see these events, it just writes it to output to Kafka topic without sampling. So their sample factor is 1. Okay? So we have our transformation spec with sample factor, and our formulas are still correct, even if some of the traffic is not sampled. Okay. So we kind of solve this problem for other teams, and now they can define their traffic and to investigate some portion of the traffic that interested. So I'd like to summarize. Real-time event is our big data model. It is built using union paradigm. Like we bring several, it is built on several types of event that we bring to one data source to Druid. It is very wide use case because it defines more than 100 different dimensions. It means that many teams can work with the same data source, because usually some teams, they need some specific attributes or fields, and other teams work with other attributes, and we bring so many dimensions that it helps many teams at Outbrain to work with it. we sample data in order to handle big scale, in order to bring to our scale is more than billion events per day. So we sample our data, and actually we found a way how to fix the data in the spec, how to build the formulas, so then the data, all the metrics are correct, and other teams can use it transparently without thinking about the sampling. And actually, all this architecture and all this model is quite flexible. Like, we started with 2 types events, and we see that it works. And we added some formulas, and we added some KPIs in Druid and also in Pivot, and we see that it works. And then we started adding more and more events. And actually, when you add more events in this architecture, you don't break the things. You write new Spark streaming job, and you add more events to Kafka topic and then to Druid. And then you can fix your formula. You can you look at the new events. You can validate them with other systems, see that it's okay, and then you can add them to the common formula. So the whole model is very flexible. Also, the sampling, like the sample the whole traffic and some do not sample part of the traffic. Also, it's very flexible. We can found a way how to use it and add more events. And so it is very useful at Outbrain, and actually that's it.